Okay, in this video, we're going to investigate another way of writing the equation of a line in the vector format. So you can see what you should have already learned previously in the core pure content here. Okay, that the vector equation of a straight line that you should be familiar with is this one here, where R represents the position vector of any point on the line. A represents the position vector of a known point on the line. We have our parameter lambda, you could use t or really any other letter. And finally, d is the direction vector of the line, so it's heavily linked to the gradient. Okay, so I'm going to come up with a different form for writing this involving the vector product. Okay, so I'm just going to write the r equals a plus lambda d here. And I'm going to rearrange. I'm going to subtract the vector a from both sides. So we'd get r subtract a is equal to lambda d. Okay, so what do we learn from this? We learn that r subtract a is equal to some multiple of d. Okay, if r subtract a is equal to some multiple of d, then r subtract a and d are parallel to each other. So r subtract a and d are parallel. Now, a key fact which we learned in the last video is that the cross product of parallel vectors is equal to the zero vector. Okay, so therefore I can write that r subtract a cross product with d is equal to the zero vector like that. And this is our vector product form of the equation of a line. Now you could expand the brackets, but I don't think that's particularly helpful. Okay, so this is the format you need to be familiar with, where once again, just as a reminder, r is the position vector of any point on the line, a is a known position vector on the line, and d is the direction vector of your line. So we're going to practice making use of this format here with this question. Okay, so we've got a straight line passing through two known points. We need to find the equation of the line in the format that we just discussed, and then we're going to use it to verify a point is on the line. Okay, so in terms of what we need to find an a and we need to find a d. Okay, so a can simply be any point on the line. So it could be this point or it could be that point. It does not matter. Okay, so I'm just going to pick a as 1, -2, 4. But you could go with the 3, -1, 6. That's fine. Now to calculate d, your direction, you need to take the position vector of 2 points on the line and you need to subtract them. Okay, so let's do 3, -1, 6, which is this point here, which is definitely on the line. Subtract my point for a, which is 1, -2, 4. Okay, and this is equal to 2, 1, 2. So that is my d. So now I can substitute into this format here. So I would have r subtract, and then it would be 1, -2, 4, close brackets. And then that is going to be cross product with d, which was 2, 1, 2, and that will be equal to 0. Okay, so that is the equation of my line in our vector product format. We now need to use it to verify that 9, 2, 12 is a point on the line. Now, in order to do this, well, the 9, 2, 12 will go in place of r, and we just need to verify that this calculation on the left-hand side does indeed equal 0. If it equals any number other than the 0 vector, then it is not a point on the line. Okay, so let's sub it in then. So I'm going to write 9, 2, 12, subtract 1, -2, 4, cross product with 2, 1, 2. But I'm not going to write equals to the 0 vector. I need to verify it. So let's calculate our brackets first. So I would get 9 subtract 1 is 8, 2 subtract -2 is 4, and then 12 subtract 4 is 8. And we're going to cross product that with 2, 1, 2. Now, there's sort of two ways we could potentially approach this in terms of figuring out whether it's equal to the 0 vector. The first way is we can actually calculate the cross product here. Okay, so ignore our top line. 4 times 2 is 8. Subtract 8 times 1 is 8. Okay, so that looks pretty good. Then ignore the middle line. And we got 8 times 2 is 16. And then 8 times 2 is 16, which we're going to subtract. And we're going to do the negative of that. And then finally, ignore the bottom line. 8 times 1 is 8. Subtract 4 times 2 is 8. Okay, and clearly that is going to come out as our 0 vector. So we can say, therefore, the point 9 to 12 is on the line. Now, another way we could have approached this is if I go back to this line here. The key fact that we looked at last time is the fact that if you cross product any vector with itself, the result is always 0. Okay, the 0 vector. So essentially what we've got here, if we look at this first vector here, another way we could write that is we could pull out a factor of 4, because we've got a common factor there. So we got 4, and then we would have 2, 1, 2, cross product with 2, 1, 2. So here we have a vector cross product with itself. Okay, so that's going to be the 0 vector times 4, which will also give us the 0 vector. Okay, so that's another way we could have approached things without doing our cross product calculation.